Yeah, Lord's holiday.
All right. Next bit.
Oh no, test.
So what we're looking at today is what's called discrete random variables. So the discrete part means whole numbers, and the random part means that whatever it is you're doing is random, like from tossing a coin, a dice, something like that. Right. So discrete only specific. Usually it's whole numbers. So things that would fit into that would be folds, runs, heads, etc. So anything like that. And so random.
When you say heads, you're talking about... Raby! Shush! When you talk about heads, you're talking about like heads and tails, right? Yeah.
All right, so random is where the outcome is determined by a random event. So coin throws, dice throw, anything like that. All right. So what we're going to do is now look at an example. So for example, if two coins are tossed, find the probability of a certain thing. So in this kind of discrete random variable thing, we tend to focus on one particular thing. So if we've got two coins, what we're going to do is focus on heads in this particular case. So if we're talking about heads, if we throw two coins, you might not get any heads. You might get one head, or you could get two heads. Alright, discrete random variables, random because throwing a coin is random.
Unless it's a...
And discrete because you can get none, one or two heads. You can't get 1.5 heads or 1/3 heads. So you would then represent this in some way, a tree diagram maybe. So your first coin, get a head or a tail. And then the next branch of the tree, again you could get a head or a tail. And you follow along those branches to see what you get. So in this case, here's all our outcomes. So in terms of what we're being asked, how many heads we're getting, this first one up here would be our 2 heads. These 2 here would be 1 head. And the bottom there is 0 heads. Alright, so when we're looking at probabilities, for A, we'd be looking no heads, so no heads is this outcome here, and there's 1 out of the 4. And so when I write probability 0 heads, and there's 1 out of our 4. 1 head, probability of 1 head, and then we have a look. There's 2 ways we could get 1 head. It's not specific about which way around, just that there's a head. So there's 2 of those out of the 4, which is a half. And the last one, where we get 2 heads, there's 1 out of the 4 there. Alright. Now when we talk about discrete random variables, the way it's set out, the probabilities is different to that, and we're going to have a look at how this might be set out. Alright. So it's what's called a probability distribution table. That's what it's called. So another way of representing this is in the probability distribution table. And then we have, we let x equal the event, which in this case the number of heads so x could be 0, 1 or 2. And so rather than writing this like that, we would write the probability that x equals 0, where x is getting ahead, and we'd say that's 1/4. And the other one, the probability that x is 1 head, we'd say that's a half, and the probability of 2 heads is 1/4. So it's another way of writing it, and in terms of discrete random variables and other stuff that we're going to be looking at, this is the way we're going to write it. Now there's also a table that goes along with this. So you can see it could be in a table, so in table form. What we would have is a table with our x across the top, and because there's 3 options, no heads, 1 head or 2 heads, and then underneath here probability of getting those things. So in the table, we know the probability of no heads, we know that's a quarter. Half here, and then a quarter. All right. There are other ways, it could be a graph as well, but this is the most common way of doing it. So, using our table then, we can work out probabilities. Now, the key thing about the table, each of these probabilities has to be somewhere between 0 and 1. Right, makes sense. Also, the other thing is these probabilities in the table have to add up to 1. All right. So if you've got more stuff, you'd have more columns, but all the probabilities have to add up to 1. All right. Yep, you're right. Call it a probability function. And the following conditions.
Did you just say the word function, Mr. Sims?
Don't you like functions more?
I love
Functions are my
Yeah,
favorite.
you're talking. Why is the table a function?
So the conditions that I just talked about is that each individual probability, Px, is between 0 and 1.
Probability of x equals x would be equivalent.
And the other thing is that the sum of all your probabilities is equal to 1.
You could graph the probabilities. That's awful.
Methods.
Yeah.
Right, so let's have a look at an example.
What do I like? A nice like 7 metres. We should go back and do IQ one.
You should just do one like further,
Yeah.
but also not.
I mean, apparently they push it nice and this dollar sack, so I'm going to take it to me.
What's chop? Oh,
Very easy.
chocolates too. It's so fucking annoying because like if you lose an arm, it's just
Right, so you might be given this time x, and x is the number of chopped chips in the cookie.
food,
How do we know the
like
ones
dust,
Oh,
chopped chip cookies.
So either get a bad chopped chip cookie and it's only got 2 chopped chips in it, or you get a good one that's got 7.
It's just a chocolate.
Solid amount.
And then we have a probability distribution. So this is might be 0.01, 0.25 that you have 3, 0.4, 0.3, 0.2, 0.2, 0.02. That's right. 4, 7, 8, 9. Yep, that's right. So this is our probability distribution. So the probability of any particular number of chopped chips is all between 0 and 1. And if you add these up, they add up to 1. So now we've got that, we can find a whole bunch of different things. So I'm just going to do one example. So we might be asked to find the probability that x is greater or equal to 4. So what's the probability? When you pick your chopped chip cookie out of the chopped chip cookie bag, that your chopped chip cookie's got more than 4 chopped chips.
Mr. Sinner, you should start live streaming.
How do you,
Live streaming, you think?
so more equal to?
More or equal to. So
you
this
count
is
up
where
how
we
much
use
that
here.
is.
Very old.
So
And
it's 74.
it will be
0.74, which would be 74%.
simply that. Yep.
Yeah, the Synonym.
Net, drawing straight lines and not actually definition.
So you just simply have a look and add them all up. So 0.74, yeah. So there's a probability distribution and a whole bunch of other stuff that you can do as well. All right. So because we're doing probability and statistics, we can use some statistical measures to help us with our probabilities. So some statistical measures are mean and then some sort of spread. So mean and variance are the ones that we're going to look at.
I think you have the same chance of getting 6 and 7.
Yeah.
Who knows? It's got to add up to 1.
False data.
So for
Did.
these discrete random variables,
I think a 1.
the mean is not called the mean.
Yeah.
What is called
I'd do that one.
Why would you sue that company?
Expectation
Well, more job chips.
variable. No
You
value.
can't sue the company because you don't have enough.
What mean?
so for discrete random variables, the mean, they call it the expectation value. Expectation value is in how many would you expect to get.
Actually, on each day.
Yeah.
All right. So it's like a long-term average, and it's calculated in the following way. Right, we use an E. E for expectation value of X. So how many would you expect to get? All right. So the expectation value, what you do is you
Is this in your heading? This is
subheading, yeah.
So that's blue.
So the discrete random variables is the big
Yeah, that's one
the
of
big
mine
bit,
as well.
and then
It was just
underneath it.
What is it?
blue
Blue.
subheadings.
So the expectation value,
Green.
what you do is you take the number you've got, whatever it is, you multiply it by the probability
But you have lots of colours.
of getting that number,
You should see mine.
and you do that for all of them, and add them up.
Do you feel like PRX or do you just write things short?
Just write P for short.
Hey, look, green looks good.
Wait, so is that just a fancy way of writing?
It's stupid.
Sorry, I wasn't listening.
It's a fancy way of writing, multiply those
People service.
and add them up.
Right. Multiplying.
So you multiply
P for surface area doesn't exist.
the number of chopped chips by the probability of getting that chopped chip. You do that for each of those,
What, is that what that thing
and then you add those numbers together.
Is that what that's saying?
So that would be how many chopped chips you would expect to get
On average.
on average in your cookie.
Smash that bottle.
Can you write that down? Like the calculator?
Yeah, I'm going to do it for the chopped chip cookies.
Somebody go buy us some chip cookies.
Yeah.
JGBs.
Quick run to Woolies.
Ew.
What is it?
I took a pact to never eat them
Why?
because I was in primary school. That's what I did. I
I'm
just
gonna
stopped
feed
it ever
you
since.
chocolate chip
I
cookies.
can't
You also
understand
took
that. You tell yourself you're not going to do something and you want to stay true to yourself.
Yeah, I made a pact with one of my friends because we had this war thing, and the war was that the chopped chip cookies were better than muffins. I like muffins, and he didn't like muffins, and he liked his chocolate chips. And he was like, yeah, so you go. And then we just made this pact, and we just said, I said, I'm not going to eat any cookies, and I'm not going to eat any muffins, and I just stuck to that ever since.
Do you think he's eating muffins?
Do you think that you're...
Fun?
Do you think he's eating muffins?
Don't know.
Almost certain.
Haven't asked him.
Ethan, the thing you made, do you remember some other pacts you made?
Yeah, I made about 47 suicide pacts. But like, none of those people have committed suicide, so I haven't do it yet.
But if you commit
It's
suicide,
increasing.
they all die.
It's an increasing probability.
Don't try and have
Right.
Let's make it 100%.
Right, yeah, because I didn't do this earlier.
Oh no.
Let's get the Cadbury.
Isn't it?
Oh, actually, there's everyone in just What's the bulk of the
See, this is the kind of maths you can get behind.
No, really.
Calculating
Try to say
my life, I could figure out if I could get a chocolate chip or not.
Oh my gosh, you should make.
Four!
You should
Four.
make.
Comes out.
What a surprise!
Four!
I'm not surprised.
No, it's kind of around the middle, isn't it?
Well,
And
it's
it's
also
got the highest.
the highest
It
percent.
does say that, right next to expectation value.
You should make our sack, like you should make our sack about chocolate chips. That would be fun.
I suppose.
And then we could celebrate afterwards.
chocolate chip cookies
Alright. So, in your bag, if you have a bag and then you have lots of chocolate chip cookies in it, you would expect that in the long term, throughout the whole bag, that
I'm down for some home
on average you'd have 4 chopped chips in the chopped chip cookies. I'm not sure that I'm too happy about those chopped chip cookies, not enough chopped chips for me.
Well, maybe they're small cookies.
Maybe, no, good point.
Or maybe
That's not even
they're
a chocolate chip cookie.
maybe they're huge choc
Put
chips.
some lentils in.
Big chopped chips, right, okay. There's a few,
The little bite-sized ones, you get them.
They're probably like one of those stupid kid those really healthy cookies that are like, oh, they have 4 chopped chips amidst the other 100
Raisins.
sultanas. Yeah, it's just bullshit like
You have
that.
to find them. Isn't it so sad, those things? And you're like, yes, I finally got a chocolate, and it's just this other
I think that's also one of the reasons why I don't eat cookies. It's the distrust.
That's actually so great. You can have that in muffins.
You can have that in muffins.
Yeah, but
Like I literally, I had that in a
I feel
muffin.
like people who make muffins have a lot more common.
I will leave this out.
Do you know people that make muffins?
I feel like choc chips in muffins
Yeah.
just
Do you know
don't
the
do
difference
that well.
other than two people?
What?
Quite literally nothing.
There's
They're both nans.
no, they're not. My nan doesn't make cookies. Biscuits are different. Biscuits are different. Anzac biscuits aren't cookies.
Oh, I love them.
Did you know that it was an end?
My nanas
Yeah.
do not make cookies. They make muffins and they make jelly slice, but they do not make cookies. And I'm proud of that.
Your names are imposters.
My nans are not a don't know make cookies.
I'm sure the chick
Fire
would make
her.
cookies. What do you mean fire?
Get a new name.
Radio.
Possibility 100%.
That's right.
right.
100% probability.
There are
minus
some patterns that I won't go through, but if you want
Right.
to really want to know it, you can look it in your textbook. But you just have to use these. And these things, I think they're on, maybe not all of them, but they're on your, some of them are on your formula sheet. So if you have age, just some number multiplied by those probabilities, then you simply just work out the expectation value and then times it by A. If you got some constant added, the expectation value of getting that constant is just that constant. And expectation value of x squared, what you need to do is square x and then multiply by the probability, then add them up. So where that comes into is if you're given information like this.
Wait, so it's the sum of x squared plus the probability of.
So you square your x, so 5 chopped chips, 5 squared, 25 times by the probability of 5. And then for all the others and add them together.
I have forgotten.
Alright, so if you're given some information, so the expectation of something is 4, and you're asked to find the expectation of 2 times that plus 5, then you would look at this situation here. So this middle one here, then the expectation value of 2 lots of x plus 5 will just simply be 2 lots of the expectation value of x plus 5. And because the expectation value you're told is 4, then you get 13.
The first two is at the top and left and right. The last one.
Oh yeah, how come the.
Why did the straight x's become a curly x?
Yeah.
Right,
Because the big X.
so
equals
the big
4.
X is the whole thing,
Oh, I get what you mean.
and the little x is a specific.
That
Possibility.
one in the second equation is a big X, right?
Do that.
Yeah?
That.
That's a big X, yeah. Same.
Like that.
Yeah.
Because it's itchy.
It's the easy way of doing
So the big X is,
it. Watch it.
the big X is the number of chopped chips, and the little x is 3 chopped chips.
Oh, okay.
So the big X just represents the whole thing, and the little curly one is one particular outcome.
Can you write big X equals all the cookies for
That was really not a classroom-friendly snack, is it?
No, but I was gonna eat it outside, but then I had to play most of it at home, and now I'm starving.
Why do you have to be something?
There, is that what you want?
Yeah.
What is
And I
it?
was not ready to.
You know what you did?
Should have got ready to know.
Break your saxophone.
Break your arm and you can't find that. I can break your arm.
Alright.
You can say,
It's your finger.
You can get six.
you can say, I didn't, but
But
that's
I don't
fine.
want to have a working arm, so I can bring it.
Right, last thing,
Actually, I'm gonna break your arm.
Beneficial for you.
measure of spread.
No, I had to shoot myself in the foot.
Oh my god, we're still going.
This is the last thing. Measures of spread, there's a whole bunch of different measures of spread.
How
The
much,
most important one that we're going to use is the variance.
is it gonna take much space up in my book?
Maybe, maybe not.
Like, well, is it more or less than the
third of the
expectation
page.
values?
It is probably a little bit more.
Oh yeah, I'm on the second page. Shit, I'm gonna have to go across 2 pages.
Start it on the second page.
No, but I don't want to, because I don't really want to. I'm just gonna make it really small.
Glenn,
Glenn, you're more OCD than I am.
Glenn, you're
My
not gonna
room
be
is
able to read it.
This will be right.
What are you laughing at?
So what variance is the variation from the expectation value or the mean. So it's how much a particular outcome varies from the mean. So how far away it is from the mean would be another one. So it is defined as the variance. So how spread out our thing is.
There's variance, standard deviation.
Yeah, that was.
Standard deviation is a different measure of spread related to the variance though, yes. And I'm going to mention that right after this. So the variance of x, how much it varies from the mean, is the expectation value
What the X on the there?
of the thing minus the mean,
It's really good at sign.
and then square it. So mu, which is the
I
mean,
hate that Greek symbol.
Where?
I never know how to
Oh,
draw it.
It's like,
It's like a U,
Yeah,
but like an
micro.
extra, it's like a P across a U.
It's a symbol.
Is that not a curve M?
no, it's a mu.
Oh no,
Oh,
like
yeah,
A mu.
it's stupid.
Mu.
So it is
mu.
an M.
It's stupid.
I think
Oh,
it's
it's
stupid.
beautiful letter.
Is that a
Racist.
square? Shouldn't it
No,
be pew?
Oh, this square here, yeah, it should be
Just move
over
it a
here.
little closer.
That's a fucking big X, not a curly X.
yeah, dickhead.
Land language.
Yeah, look, my 8 subscribers might get offended.
We'll get demonetized.
I subscribe, just saying.
Maybe I'll get money on
He isn't monetized yet.
It's okay, they'll make you a deal soon.
There are
Alright.
5 people in this
You'll get
class.
some.
The people who haven't subscribed are traitors.
I know she should.
Alice!
How do you think? I know she, I know you.
I don't think I've ever been
I
on
know
the
you.
site.
Pardon?
I don't think I've ever been on Twitter.
How did you know that you're doing that? Fair enough.
What do you do in this class? Wow.
I
Don't catch
don't
up.
really miss classes.
What do we do for quality content?
Alright, then mention the standard deviation.
Is
that a
what
big
is,
X
what
or a
the
little
fuck
X?
is that?
This one here is a big one.
What do you call that?
Oh shit. I-
Sigma. It's lowercase sigma.
A lowercase sigma. What does
Sigma.
sigma mean?
It's a Greek letter.
In the alphabet.
Yeah, what does it do?
Well, when they write, they use it to write.
Why don't
What?
It's like Y or something.
Because
It's like gamma.
of the Greeks' connection to
The
mathematics.
first mathematicians were Greeks.
I don't.
Well, then it's
So it's just a variable.
Yeah.
Yes,
Yeah, just a variable. Alright, and the variance is often written as sigma squared, where sigma is the standard deviation. So the standard deviation, sigma, sometimes it's written as SD. Standard deviation of x then is simply the square root of the variance.
I remember using the calculator.
No, there's no hero. We didn't have the fancy calculator.
Alternatively, for the variance,
Oh, horse lady.
Oh, Miss Thomas. Too much life.
Horse
Shit, Thomas. She was good if you were like.
She had two rabbits.
She was good if you were like Lacey.
Or Sammy.
Why does she love me so much? Like this up. Lacey was the genuine worst. Like, why did Miss Thomas love her so much?
Maybe because Miss Thomas was also the genuine worst.
True. Remember what was her? She really liked
Horses.
No, there was a song. By that rap song by Dr. Is Still Dre maybe?
Dr. Dre.
Is Still Dre, or it was one of his. It was one of those songs off that Dre album.
What are we
You
talking
know the other one's like.
Miss Thomas.
da-da-da-da.
Oh.
How do you remember
yeah.
that?
Snoop Dogg. That one.
Yeah,
That's smoke weed again.
Yeah.
No.
Smoke weed every day.
no, I think it's,
Because she's
yeah, I
smoked
think,
weed
I
every
think it's
day.
either still DRE
I think it's the other one.
or it's,
Did you just say
Still
DRE?
DRE
She
is
used to
different.
smell
It's like
like cigarettes. So that.
Yeah.
Or is it the next episode?
Next episode, that's the
That's
one.
what it is.
Cool.
With
I'm
the
gonna
sound
be
effects.
fuck.
It's, I don't know, that song is so old.
Yeah.
It's like 20 odd years old.
Bro, have you seen Snoop
The
Dogg?
album?
He looks like a grandma. He dresses like one
Yeah.
too. I wish he was like
He's on that cooking show.
Was Martha Stewart?
Yeah, I love how there's a
So
whole
good.
generation of people that don't remember he was accused of murder.
Was he?
Right, nearly done. An example, and then
Yes.
something I need to point out, and then we're done.
Actual murder.
Did he get convicted?
Actually,
Well, obviously not.
Space blend.
I'm gonna make this actually. Oh shit, I'm not gonna do it.
Just screw the example. Drop it.
Oh,
Friends like, I really do.
Quick joke about it. I was not like that.
Job methods and like there were 6 weeks left of school.
I'll just get unschooled actually.
Glenn, what are you gonna do, man?
Happy.
So you can be a stripper.
It's my goal in life, is to be happy Jed.
Where do you want to go to uni? Are you going to uni?
Yeah, like it depends on how good my ATO is, so
Same man.
it'll be like online university if I have to. I hope
It'll be what?
online uni if I have to, but hopefully we're going to get to that stage.
Just do some tape and then just become a doctor because people do. Insane.
that easy.
That's what my sister did. She's doing like neuroscience or some shit.
How many years is she gonna be studying for?
I don't know, like.
My whole life.
No, I think she wants to go into psychiatry. Yeah.
Why would you do neuro?
Yeah, psychologists require the brain.
She's just bouncing around, but our uni is literally just like, if you like start down here, you can just Tetris your way up, and then,
Oh, Mr. Stinnett. I wasn't done.
I'll tell you what, I'm just gonna.
Just catch up.
You shouldn't let Ethan distract you.
You are correct, Mr. Stinnett. Oh, you're right.
What's Sol N?
Solution. I'm too lazy to write a whole word, Lara.
What?
Is that all right with you?
Yeah.
Is that alright?
Yeah.
So that's the answer.
All right, so the mean is the expectation value of this. So the expectation value, what do? We multiply and add them
I'm
up.
going to say it'll be 2.
Well, it might be,
It might be 2 and a bit, but
2 and a bit.
Mate, is it
yes.
little like something?
it'll definitely have 2.
Does it?
I feel like his
I
little
reckon it's
accent's
probably going
okay.
to be,
Was
might
it
be 2 and a bit.
SD of little x?
Yeah.
It was.
SD, standard deviation.
Standard deviation.
All right, you're right, Nicole.
Of course I was.
What's 2?
No, unfortunately not.
Good guess.
I was right.
Good estimate.
People cause to be straight.
Yep, and I just...
People's asking for it.
All right, so our mean is 2. Now, most often the easiest way to work out the variance is going to be with this particular version, because we've already, in here, we've already got the mean. So we've got what we've got to do for the expectation value of x squared is similar to what we got here, but each of these is going to be squared. So the expectation value of, so the variance is the expectation value of x squared minus
Are your eyes
the mean
cheeky?
squared.
I'm gonna hit your eyeballs, so I'm gonna make sure that I come back out.
So in this bracket I'm going to put this bit.
Yeah,
So
eyes never come out.
we've got to square our x and times it by our probability.
That
So
was
0
so
squared
cool.
times the probability.
So terrible.
That was pretty bad.
Pop B.
1 squared times the probability. 2 squared times the probability. 3 squared times the probability. And from that, we're going to take the mean, which is 2 squared. And when you do all that on your calculator, oops, you get 0.84.
There's some really uneven lines.
Is that the end?
Right, just one note.
Oh my gosh.
One note about probabilities.
It's so good, June.
So for many random variables, about about 95% of the distribution is within 2 standard deviations of the mean. Right, what does that mean? It means that probability of x being within 2 standard deviations of the mean, in other words, the mean minus 2 standard deviations, to the mean plus 2 standard deviations, the probability of x, the number of chocolate chip cookies, or chocolate chips in your cookies, probability of something being in that range is approximately 0.95. Alright, that's it. 13C and D.
And when are we going to have time to do this? Is that it?
Oh, look on Jed's phone.
And you got 4 minutes to get that completed, aren't you?
Great! Sounds so achievable.